All right, welcome to part 2 of the inverse trig functions. In this video, we're going to go through some problems that will require multiple either inverse functions or just the regular functions. If you remember working with function calls and we had composite functions, what you want to do with this is actually start working from the inside out. So the first thing you're going to do, and if you think about order of operations, it tells you to do what's in the parentheses first. So we are going to start with the inverse cosine of root 3 over 2. Now, the other thing I did is I have a very small copy of my trig chart and ASTC chart right here, and I will keep basically pasting it in other places as I need it. So let's see, inverse cosine of root 3 over 2. So I'm going to go to cosine, I'm going to find root 3 over 2, and I'm going to figure out where that is. Well, that's at pi over 6. So this whole piece right here is just pi over 6. Now what I want to do is find the sine of pi over 6. And that's actually the straightforward thing that we've been doing for a while. So I'm going to go to sine pi over 6, and oh look, the answer is 1/2. So the answer to problem number 1 is 1/2. So I'm going to box that up, and I'm going to move on to number 2. All right, so problem number 2 right here again, start with the inside here. So I want to know what is the tangent of pi. Now that's actually a straightforward question. It's the ones that we've been working on. So I'm going to zoom in on my ASTC chart right here. Okay, and tangent of, well, here's pi, and here is the ordered pair. Now, one thing to remember, tangent is sine divided by cosine. So the sine of pi divided by the cosine of pi would be 0 over -1. 0 over -1 is just 0. So let me zoom out here. All right, so this piece right here just turns into 0. And now I'm looking for the arc cosine of 0. Now remember, arc cosine is the exact same thing as inverse cosine. So I want to know where is cosine, or what radian measure gives me a cosine value of 0. That's what that inverse cosine says, or arc cosine. Cosine here, no 0 in my trig chart, so I'm going to slide over to my unit circle. Now, one thing to keep in mind with cosine is I'm only dealing with the top half of the unit circle. So cosine is my x value right here, up at the top here is where cosine is 0. So there's the 0, and that's at the radian measure pi over 2. All right, so this is going to be an answer of pi over 2. Box it up, double check. Yep, okay, we're good. I wanted to make sure there wasn't a third piece to do there. All right, problem number 3. I am going to start with the sine of pi over 2. So the sine of pi over 2, and pi over 2, remember, is on the unit circle, so it's right here. I was actually just zoomed in on it, so I'll zoom in a little bit better. So pi over 2 right here, the first value, the x value is cosine, the y value is sine, so I'm looking at 1. So the sine of pi over 2 is 1, and now I want to know the inverse cosine of 1. So what I'm asking for is, at what radian value do I have a cosine value of 1? Now, cosine does not have 1 in the trig chart, so I'm going to slide over to the unit circle, remembering again that cosine is the top half. The inverse cosine is the top half. And right here is where cosine is equal to 1. Now, I either have the option of 0 or 2 pi, but remember, 2 pi is outside of cosine's domain for the inverse function, so I just want to use 0. So that's going to be 0 here as an answer, and we are done with problem number 3. All right, number 4. I want to start with the arc sine of pi over, I keep saying pi over 2. It's actually root 2 over 2. I'm going to say the right thing eventually. So inverse sine, when is sine, or at what radian measure is sine equal to root 2 over 2? So I'm going to go to sine, find root 2 over 2, and that radian measure is pi over 4. So this part right here is pi over 4, and I want to know then the cosine of pi over 4. Well, cosine of pi over 4 is root 2 over 2. Now, of course, that's not going to happen all the time, but because we're dealing with that pi over 4, and both sine and cosine have the same value, so it just happens to be the same thing here. So root 2 over 2, no negatives or positives to worry about there. All right, so problems 1 through 4 are done. I'm going to go ahead and slide down to 5 through 8 here. I'm also going to see if I can quickly pop in. There's my paste. Hey, cool, it did work. That was the last image I had, so I'm going to keep it in there. We'll make it a little teeny tiny. We'll make it work. All right, so let's start dealing with problem number 5. All right, so I want the arc cosine of negative root 2 over 2. And I got to be careful here. Because it's negative root 2 over 2 and I'm dealing with cosine, my cosine value is going to be somewhere over here in quadrant 2. So I'm going to find the inverse cosine of root 2 over 2. Inverse cosine root 2 over 2 is pi over 4. So now I need to be pi over 4 off of the x-axis here. So this is pi, and remember I can rewrite this as 4 pi over 4. That's simply to make the denominators match. Okay, that's all that. The only reason why I used 4s there is to make the denominators match. So if I took 4 pi over 4 and I subtracted pi over 4, that will tell me where I am in my unit circle, and that's going to be 3 pi over 4. All right, so now I want to know what is the tangent of 3 pi over 4. So tangent of pi over 4, because that would be my reference angle, tangent of pi over 4 is 1. All right, so that's good enough. That's 1. However, 3 pi over 4 is in quadrant 2. And in quadrant 2, I'll zoom in on this piece right here. In quadrant 2 right here, there's an S. And remember that S means that sine is positive, but all the two other major trig functions, cosine and tangent, are going to be negative. So that means I need a negative 1 for my answer here. All right, so be careful when you're dealing with the negatives, because you got to pay attention to what quadrant you're in, or if you're dealing with negatives or positive on the unit circle. So just be aware of that. So problem number 5, the answer is negative 1. All right, let's see what number 6 is. I'm looking at the cosine of pi. I know it's kind of hard to see, but it's down here. I'll zoom in just a little bit. Oh, I can actually do that. That's not too bad. So cosine of pi is going to be negative 1. All right, so let me get a pen here. There we go. So that's going to be negative 1. And then I want to know the inverse tangent of negative 1. Well, the inverse tangent of 1 is pi over 4. Because tangent, in order to make it negative, needs to be in quadrant 4, we can actually just make that reference angle negative, and it will put it in the correct, it'll put it in the domain correctly. So negative pi over 4. All right, so the idea here is in quadrant 4, we would have been here at pi over 4 negative, because that's the, basically instead of going up to rotating positive or counterclockwise, we're going to rotate clockwise, then I'll get the negative. That would be in the domain. All right, so that's problem number 6. Let's talk about number 7 here. Now, 7 and 8 have 3 things going on, which is no different than having 2 things going on. Just start with the innermost set right here, and we're going to work our way out. All right, so I want to know the tangent of pi over 4. So tangent of pi over 4, so let's see, tangent pi over 4, well, that's 1. All right, so that's just 1. The next thing I'm going to figure out, and I'm going to work my way outwards, right, and I'm going to also put the other pieces in place here. So the next thing I want to do is look at the inverse sine of 1. So that, let's see, inverse sine of 1. So I'm looking for a y value on my coordinate grid of positive 1, which is right here at pi over 2. Okay, so this is going to turn into pi over 2, and now I want to know the cosine of pi over 2. Well, go back to that exact same coordinate pair, but instead of looking at the y value, I'm going to look at the x value, and that x value is 0. So the cosine of the inverse sine of the tangent of pi over 4 is equal to 0. Folks, make sure you're showing your steps, all right? 100%, make sure I see those steps so I know if you make a mistake, I can see where the mistake was made. And trust me, if you just write down an answer, you're not getting much credit for this. I'm being 100% honest, okay? So show your work. All right, last one. Now, we've got the sine of pi over 4. Now, I'm going to do one thing that I haven't done yet. And I'm going to look at the exact next piece here. Sine and arcsine are inverse relationships to each other. They undo each other. And if you think about it, and I'm going to write a quick problem off to the side, when way back in Unit 5, the very first unit this semester, when we had something like the sine of theta equals 7/9, and we needed to solve for theta, we would take the inverse sine of both sides. And what I told you guys was sine and inverse sine would cancel out and leave you just theta. This is still true. So when I look at arcsine and sine, those two operations undo each other, and all that's left is the tangent of pi over 4. Okay, now that only works when the two operations are the same. So if this is sine and arcsine, this would work. Or if this is sine and this is arcsine, that would work. Obviously, it's not going to work if this is tangent and arcsine, right? Those are not inverse operations to each other. So it only works if you've got arcsine and sine, arctangent and tangent, or inverse cosine and cosine. So just be aware of that. So now having simplified those first two, right, those first two are done, I want to look and see, okay, well, what's the tangent of pi over 4? And the answer is 1. All right, so this whole thing just turns into 1. All right, so that takes me to the end of this video. Problems 1 through 8 are done. Those are the combination problems. Let me know if you have any questions or concerns, and I hope this is helpful.